Okay, we're on part 2 of section 8.3, and we're still reviewing, making sure everything is on the up and up. We're talking now permutations. In section 8.1, we did multiplication principle and also permutations. We talked about a factorial, that exclamation number, and we said order was important. So that each position of 3 elements is the key to a permutation. So there's more of them than in combinations, because combinations are group. So for our calculator, we construct a permutation as NPR, where N is the cardinal number of all elements in the set, and R is the size of the elements to be arranged. All right. When I make it try to fit, I make a mess. All right. So here we had permutations. And then our last one of counting principles is combinations. One set, as in permutations. I don't know if my tablet is dirty right there, but my pen does not want to work right there. That are in order is not important. Again, so in this case, we use a C because of our calculator, and CR, just the same description as what we had for our permutations. Same description, only this is grouping, and permutations is order specific. And remember that our book uses the P of NR and the C of NR, all the same methodology to determine what our total number of elements and the size of whatever we're organizing. So we're going to do examples analyzing which counting principle to use. A bag contains 6 red balls and 6 blue balls. If 4 balls are selected at random, find the probability of selecting 4 red balls. Okay, in this accounting principle, we would first have to figure out total number of selection of 4. Oh, well, actually, of elements. Set. And here we're talking 6 red plus 6 blue, 12 total. All right, so we have that because we want the probability that we select 4 red balls. And we're assuming one at a time. Probability to exist. We understand that we have the probability of 1 red and probability of 1 red and probability, and that means and here, probability 1 red and the last one, and probability of 1 red. Well, we're talking about selecting from a back. So, and means to multiply. So here we go. So if I wanted 1 red out of whatever we have, which was 12, we would say our first pull and second pull out of the bag and third pull and fourth pull. So all of these pulls reduce our sample space of 12 by 1. So we're going to make the assumptions we pull a red one. So that would be 6 out of 12. And now we have 1 less of the red and 1 less in our sample space. So we'd have 5 red out of the 11. And if we pulled a red one the second time, that gave us 4 reds out of 10. Again, we've taken 2 red balls out of the item. And then we're going to have for the last pull 3 out of 9. All right. And this is an and, so it's multiply. So this means we can cancel some things. Like we can go to this and say 1 over 2. And then we can go to this and say 5 cancels 10 twice. And then we can do 2 cancels 2, so I have a 1 there. And or we can stick it in the calculator, whichever way you want to go. Well, I notice that I have a 1, 1, and 1. So I have 4 in my numerator. And then I have 11 times 2 times 9. Well, that's a little bit more than I wanted to do. But let's see what I've got. I've got 22. And let's see what I have. Oh, that's a 3. Oh, I did a mistake there. I saw it as a 2. Sorry about that. This is a 3. And I did not the 2. So this is 2 and this is 2. Okay. So I made a small mistake. Let me do it again. Let's see. I had the right. I had 6 out of 12, 5 out of 11, and I needed to use red so I wouldn't mess up. 4 out of 10, and 3 out of 9. All right. So this reduces to 1 and 3. This reduces to 1 and 2. This reduces to 1 and 2. So now I can see what I have. Sorry about that, class. Again, haste makes waste. So I'm going to have 4 in my numerator. I have 6, 8, 88, doesn't it? 6, 12, sorry. And let's see what else. Oh, I gotcha. I have 6 out of, and I'm going to multiply these across. So 6, 8, 88. And then I'm going to divide by 4, and I get 1 out of, and this looks like, right, 6 times 2 is 12. Oh, can't do math. And I have another number missing, 3. 132, sorry about that. So if I divide by 4, I'm going to get 3, 1 out of 33. There it is. That's my answer. Thank you. And you can just stick it in the calculator, which I should have done. And I'll show you how to do that. Here we go. And it's a new key we can use. We know it's 6 divided by 12 times 5 divided by 11 times 4 divided by 10 times 3 divided by 9. Enter. We get this ugly thing. Then we go math, and we're going to enter frac, and enter, and we get 1 out of 33. And I should have done that for you. All right. But what can I tell you? Best laid plans. Here we go. A basket contains 8 red, 1 yellow, apples. Red and 1 yellow. Okay, so I have a total of 9 apples. All right. A sample of 5 apples is drawn. Find the probability the sample contains at least 4 yellow. Oh my goodness, I have a typo there. Should be 11. There you go. All right. So in this case, we're saying at least. All right. Here we go. So that means that we have yellows are 11. 11 out of the 19 for the first draw. And for the second draw, 10 out of 18 times, and then, okay, so we're needing at least 4. And so, oh, well, that would take us forever, wouldn't it? So we're going to do combinations. It would be too hard. We would have to do what we need to do to get this answer. So we're going to do the quick and do combinations. All right, here we go. So at least 4. So we want 4, choose, 11, choose 4. And then we would have out of the 4, and we're talking at least 4 yellow apples. And that means, okay, so we can have 0 out of the red. Oh, a basket contains 5. Oh, okay. So 10, choose 1. All right. So then we can have at least 4. Now I want 5. And then I have 6. No, 5 is the extent, right? 5 apples drawn. Okay. So this is what I have over, because we want probability. The total is 19, choose 5. All right. So we have here something that we're going to do in pieces. And we're choosing 4. And I'm going to go like that. Up arrow, side arrow, times, and then I have 8. Why did I put 10? Oh, 8. 8. Math. PROB. 3. Choose 1. That makes it 2640 for that one. Plus, I'm going to have 11. Choose 5. Side arrow times, and that would be 8. Math, and we know this is 1, but we're going to do it anyway. We're going to 0 because we got all 5 apples. 462. And then we're going to do the total amount of our sample. Oops, sorry. We're going to do 19, math, PROB, 3, choose, oops, go back, forgot the 5, 5. And we have 11,628. All right, so now we're almost there. So we're going to have 262. 2640 plus 462 in parentheses divided by 11628, and I get a decimal. I don't want a decimal, I want a fraction. So I do math, frac, enter. And then I get 517 over 1938. And that's the probability of getting what we were looking for. And if we did the decimal, we would say, I don't remember what the program wanted. It's usually about 4 decimals. But this is the fraction, exact answer. This is an approximation. I just don't remember what the computer wanted. It probably wanted a decimal, to be honest with you. So, but you have both for the notes. All right. 2 cards are drawn from an ordinary deck of 52 cards. What is the probability that 2 are the same suit? All right. So we're only talking 2 cards. So we know there are 13 cards in suit of hearts, diamonds, spades, and clubs. 13. All right. So this is our sample space. And our R of 2 cards is 2. All right. So out of that, we can set up our combination because the order is not important. So we're going to do 13, choose 2 is number of pairs from one suit. Now, how many suits do we have? Well, we've got 4 suits. So we're going to have that, and then we're going to multiply it by 4. And then for the bottom, we're going to have total cards is 52. And we want to know how many pairs we can make. So that would be 52 choose 2 for our total sample space. All right. So now we're going to construct the problem. The probability. We're going to have 4 times 13 choose 4, because there's 4 suits in a deck of cards, over 52 choose 2. Okay, that's our problem. So we're going to do first the 13 choose 2. Sorry, I put 4 on there for some reason. There we go. And so I'm going to do that first. So I have 4 times 78 over. Now I'm going to do the 52, math, P-R-O-B, number 3, and we're doing a pair of each. This must be huge, right? It is. 1, 3, 2, 5. All right. So what we're going to do now is either reduce or give a decimal value. But I think on this one, we're going to do a decimal value. No? Or we'll do both. We'll do both. So here we go. We're going to enter it. 4 times 78 divided by the 1325. And I get this number. And I'm going to do 4 decimals. If they want an approximation, this is the answer. Well, what do we want? A fraction? Math, enter, enter. And we get, sorry about that. It didn't reduce. So either this guy or this guy. I'm probably, it's a decimal, no doubt. All right, so let's do another one. These are easy, easy, easy. Think about what's happening. After studying all night for a final exam, a bleary-eyed student randomly grabs 2 socks from a drawer containing 11 black socks, 8 brown socks, 2 blue socks. All mixed together. It looks like 21. All right, so we've got this value here. And all mixed together. What is the probability that the student grabs a matching pair? All right, so we have all kinds of conditions. So we have the black socks, so that would be 11 choose 2. Then we have the brown socks, and that's 8 choose 2. And then we have the blue socks, and that is 2 choose 2, right? Or to, yeah, because they only have 2 blue socks. All right, So we know that one's 1. And they're an and. This and that and that. So on this one, let's do that. Oh, 11, math, PROB, 3, 2. There we go. And we get 55. Eight, math, PROB, number 3, and we're choosing 2. 28. And if we're lucky enough, 1. That's 13, 14, carry the 1, 6, 8. 84. Okay. So there are 84 ways to pick a pair. Now we need the total, right? So we had 21. Total number of pairs possible. 21, math, PROB, number 3, 2. And we get from that one 210. All right. So now we have our probability. So we have the 84 over the 210. And we can reduce that. So let's do that with our calculator. 84 divided by the 210. And it's 40% or 2, and that would be 2/10, right? Oh, I didn't hit frac. 2/5 rather. And since that's a beautiful fraction, I know it'll want a fraction. All right. So now we're getting to this one. And we're going to be talking about repetition of letters. That's an E. There is no distinction between repeating letters. Therefore, count them and divide by factorial. Right. So let's look at this one. It's giggling. So the letters are G, I, G, G, L, I, and G. All right. So on the G's, we have 1, 2, 3, 4. On the I's, I have 1, 2. And L, I have the G, the I, the L is only 1, and the N is only 1. So I have, these are the repetitions. All right. So what do we want with this giggling? If the letters giggling are chosen at random, what is the probability? So we want the probability that they spell out the word giggling. All right. Well, there's only one way of getting giggling, but in this case, we're saying that we have, I don't know, 8 factorial. It's a permutation. Order important. So what we have here is how many? 1, 2, 3, 4, 5, 6, 7, 8. We have 8p8 as the total number of arrangements that we have with the letters. And we're going to divide by their repetition, which is 4 factorial times 2 factorial. All right. So in this case, we're going to do the multiplication and get what we need. We're going to do 8 math, PROB, number 2, and 8, or 8 factorial, whichever way you want to do it. You're going to get the same thing because same number. So this guy is 4320. And the bottom we have 4 factorial times 2 factorial, which we know is just 2, but we're going to do the factorial because we understand that it has to be a factorial for this consideration. And we get 48. So now what we're going to do is divide it out and then make a fraction. $40. Right? So now this tells us how many ways, not the probability is, but how many ways. Without duplication. All right. So now the probability is how many of giggling do we have? Well, there's only one method out of the 840. It's our probability. That's it. All right. Now let's look at this guy right here. Shipment of 10 printers contains 2 that are defective. Find the probability that a sample size of 3 drawn from the 10 will not contain a defective. Will not contain a defective. Alrighty then. So if we have 2, then they're not going to be defective. We want 3. So what do we want? So we want good, good, good in any form we need. Good, good, good. So we're going to have um, we're going to have the sample 3 from 10 will not contain a defective. So we want only good, right? Out of the 10. How would I say that? So we would then say 1 minus uh, uh, less than or equal to 2 defective. Okay, because we want the probability that out of the 3, we're not going to have 2 defective or 1 defective. So this part here is going to be 2, choose 2. And then we're going to have or and to choose 1. And 8, choose 2. And this one, I forgot the other one. Okay, because there's 3. Hold on. Times 8, choose 1. And 2, choose 1. And 8, choose 2. In either case, we're going to have 3 of them. And this is our total probability of having that over the total, which is 10, choose 3. All right, got it all. So this is all over 10, choose 3. Okay, got it. So I'm going to do math, PROB, number 3 and 2. And of course, that's 1. And 8, choose 1 is 8. 2, choose 1 is 2. 8, choose 2, well, let's find out. 8, math, PROB, number 3, choose 2 is 28. Math, PROB, 3, and we're doing 3, 20. So, as we do the math, let me see if I can do without it. So I'm going to have 8 plus 56, right, over 120. That gives me 64 over 120. And now I'll use the calculator again. Okay, and that's going to give me do math frac, 8 out of 15. So let's review again. We had a total of 10 printers, 2 defective. We want them all to be good, none to be defective. So it's 1 minus the probability of 2 or less defective. Okay, so I'm going to have this condition here, which is 2 defective, choose 2, which is only 1. 8 good ones, choose 1, and that means 8. 2, choose 1, and then 8, choose 2. So I have 8/15. So I have 1 minus 8/15. And when I do that, It's going to give me 7/15. 7/15. Very good. That was tricky because it's one less than defective ones. And the defective ones, we can only have three of them at one time, right? So this is 2 and 1 is 3. And this is 1 and 2 is 3. These are the good, and the 2 is a defective. All right. Good job. That was thoughtful, not hard. So let's look at this long one. And this long one is about books and authors of books and what happens when we want to find the probability. A conference promoting excellence in education, special education books were selected to given away in contests. These 7 books written by author A 6 books from author B, 7 books from author C. So we have 20 books total in our sample space. All right. The judge of one contest selected 6 for prizes. Find the probability that the selected consisted of the following. Remember, order not important, so it's a combination. All right, a combination. Here we go. 3 author A books and 3 author C books. All right. So we want the probability of 3 A authors and 3 C authors. All right. So that means that we have, in combination of A and C, we have 7, choose 3, and 7, choose 3 over, and the total was 20, choose 6, 3 and 3. All right. So, okay, let's do this. And of course we have, and I could have written, but that would be 1. The book puts it like this to make sure that you understand that we have A, B, and C. And there would be, and 6, choose 0. And we know that's 1, so I don't know. However you see it is good. So let's do that. 7, math, PROB, and we're doing 3, and we're choosing 3, 35. 20, 20, come on, Elmer, 20, math, PROB, number 3, choose 6. And that would be 38760. All right, so let's do some math. 12, 25. And we're dividing by the 38760. And we need the decimal to 4 decimals. And we have a very small chance of getting that condition in the pile. Exactly 5 author B books. Exactly 5 of author B books. All right, now remember we're giving away 6. So we want the probability of 5 author B and then the 1 of other. All right, so, okay, we're going to do this one. So we're going to say combination. The B book is 6. And if we take 6 from the 20, we have 14. Or we do them separate. Okay, let's do them separate so you'll see it better. And times 7, choose 1. And that's from author A. Plus 6, choose 5 times 7, choose 1, which is author B. All over what we already have, which is 20, choose 6. All right. All right. So let's do that. 6, math, PROB, number 3, and we're choosing 5. And I get 6. 6 times 7, because if I'm choosing 1 from the other one, it's that. And this is the same, 6 times 7. All over what we already found out to be 38,760. All right. So that's 42 twice. And that would make it 84, wouldn't it? And we'd have a very small decimal. Oh, 2 zeros. Sorry about that. 2167. Okay. 1, 2, 3, 4. Okay. So it would be 2, 2 after we round it. Okay. Well, now we're doing this guy. All of them are what we said. Author A, 4 author A, 1 author B, and 1 author C. So we want the probability of 4 A's, 1 B, and 1 C. All right, that makes our 6. So we're going to set it up as, here we go, 7, choose 4 for A. And a 6, choose 1, and 7, choose 1 over 20, choose 6. 4, 5, 6. 6 books. All right. So this one doesn't look too bad. So we're going to do 7, math, PROB, number 3, choose 4. And that is 35. 35 times 6 times 7, because we're choosing only one out of that group. And this number right here is 38,760. So we're going to multiply that numerator together. 35 times 6 times 7, 1470. Out of that same number that we've had, 38,760. All right. So we're going to divide that out. I'm going to get 0.03795 dot 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 1 2 3 4 0.0379. No change. Make sure you use good rounding rules so you won't get frustrated. Okay. Oh, we're getting this guy right here. We're almost done with the lecture. At least, oh, here is that word, at least. That means it can be more, but it can't be less than 4 books from author A. So in this case, we want a whole addition process to get to the 6, and it's author A. So that's 7, choose 4, okay, and that means times 6, choose, or do I do 10? 13. Let's do 13. Now, we don't have to do them all crazy. All right, so we're going to lump everything else. Okay, now let me explain that. We have 20 total, and we're taking out 7. That's 13 left. All right, so that would be 13, choose, and then we're doing 6, so that's 2. Plus 7, choose 5. Times 13, choose 1. Plus 7, choose 6. Times 13, choose 0. All right, all over, this is probability, 20, choose 6. Okay, so here we go. Let's do this one. And we want the probability of at least 4. At least 4, or 5, or 6. There you go. There's that. Here we go. Now we're going to do 7, 4. That's 35. Remember, you can do it all at one time. I'm just making sure you don't get lost in the lecture. And that's 78. Now I'm doing 13, choose. Choosing 1, because we did 5. And if we choose 0, it's times 1. So now we're going to just do the numerator. 78 times 13 plus 7. So we're now going to divide by the 38760. All right. So that's our probability, at least for author A, out of the 6, at least. Now we're at our last one. No more than 2 books written by author B. So author B can only have at most 2, no more than. So this means the probability. So we're going to structure the problem. So we can have 2 of B. So we're going to have our 13 again. So we're going to have author B, right? They want B is 6. Make sure. I've done this a lot, but let me go up here. Author B is 6, and they want no more to it written by author B. So we want 6, choose 2 times, and then I have 6 from 20 minus 6 is 14. 14, choose 4, because we need a total of 6, plus 6, choose 1 times 14, choose 5. Because those are the only opportunities that we have no more than 2 books from author B. All right, so author B. Here we go. All over the 20 books, choose 6. Okay, here we go. 6 math, PROB, number 3, and we're choosing only 2. 14. And 14, math, PROB, number 3, choose 4. 1001. 6, math, PROB, number 3, and we're choosing 1. Well, that's 6. 14, math, PROB, oops, sorry, 1 too many, 3, and we're choosing 5. And this we've already know is 38760. So we're going to do the math now. So I have 15 times 1001 plus 6 times 2002. 13527 divided by 38760. That equals let me read, no more than 2, written by author B. Okay. 0.34899, blah, blah, blah. 1, 2, 3. So that is 0.3490. No more than 2 books written by author B, and it can be all the rest of them. So we've got that probability. So there you have it. All of this lecture is done. So now you've gotten all the probability with all the counting principles. Thank you very much for listening.